Greeting pre-calc students. It's time for math weirdness with Winter again. I hope you're having a good time. I hope you're following the lessons I'm putting out. But this particular lesson is entitled Graphing Trigonometric Parent Functions. We'll get into the transformations and stuff later. I just want you to get this basic stuff down. This will be our first lesson, or lesson 1 in the trig graphing unit. Now, what you're going to find out is we've been doing all this weirdness, solving triangles, law sines, law cosines, reference angles, all that stuff, unit circles, out the ears, that kind of a deal. Now I'm going to show you why that unit circle and why I stressed it so much, I guess why it's so important. So if I go here, I'm going to use a little unit circle here, and really I'm not going to concern myself with every little pi over 4, pi over 6, whatever, 3 pi over 4 angle in there. I'm just concerned with what are called the quadrantal angles. That's like 0, pi halves, pi, 3 pi over 2, and 2 pi, the quadrantal angles. It's the one where the angle's terminal side lies on the axes that make the quadrants. And remember, if you will, by definition, a unit circle is a circle of radius 1. So let's just go and, instead of doing a complete unit circle, we're just going to fill out 4 coordinates. So if I'm right here, that's at 0, 0. I go 1 unit to the right, that gives me a coordinate of 1, 0. If I go 1 unit up, that's 0, 1. 1 unit left is negative 1, 0. And 1 unit down is 0, negative 1. Now, how is this going to translate into a graph and a table? Well, if you recall, I'm not doing tangent. Remember we talked about the sine of angle theta being y over r? And since by definition our unit circle has a radius of 1, basically the sine is your y-coordinate on the unit circle. So if I want to find, well, what is the sine of 0? I go here to the angle 0. Here's x, here's y. My y is 0. Pi halves right here. My x is 0, my y is 1, my sine is 1. Here, my x is negative 1, my y is 0. Again, the sine is the y, so my sine is 0. 3 pi over 2, here's x, here's y. Since sine is the y-coordinate at 3 pi over 2, my sine is negative 1, and then again back to 0, which is 2 pi. My y is 0. So what do I do with that? Well, I plot them. 0, 0. Pi halves, 1. Pi, 0. 3 pi over 2, negative 1, and 2 pi, comma 0. And that graph right there, ladies and gentlemen, is what one cycle, one period, one iteration of the sine function looks like. Now, the sine function is what we call periodic, which means what basically? Well, it means it doesn't just go from 0 to 2 pi. It's not bounded just by these angles. Remember how we talked about circles, the unit circle, the angles can rotate as many times as what we darn well please? So that's what's going to happen. So the sine graph is going to just keep repeating the same pattern over and over again without ceasing. It just goes on and on and on forever. Now, before we go on to like the cosine or the tangent, let's play a little bit because, well, we can, and it's my video and my time, so I'm going to do that. I want to talk about 3 things here. I want to talk about, number 1, what is the domain for my sine function? Well, my domain for the sine, quite simply, is it goes on forever in the left direction. It goes on forever in the y direction, in the right, so it goes from negative infinity to infinity. My range. Again, I'm opting to use interval notation. How low does it go? Well, it goes to -1. How high does it go? Well, it doesn't get any higher than 1. So it's from -1 to 1 with a bracket including it. Now, the last thing I want to talk about is what is called the period of the function. What that means is this. I understand that the sine function goes on and on and on forever like that, but what does like one cycle, what does one thing, what is just one whatever of the sine function look like? And that happens in here. Or in other words, how long does it take for it to do one cycle of the sine function before it starts repeating the pattern over and over again? So that goes from 0 and ends at 2 pi. So how far apart is 0 and 2 pi? Our period is 2 pi. That is the length of that interval for the angle. That's the sine. Okay, let's take a shot at the cosine now. Again, by definition, cosine of theta is defined as x over r. Recall that in a unit circle, r is 1. So if I make that little ghetto unit circle like I did, if I want to find what the cosine is, all I got to do is look for the x-coordinates. So I'm going to repeat that pattern. At 0, my x-coordinate is 1, so my cosine of 0 is 1. At pi halves, my x-coordinate is 0, my cosine is 0. At pi, right over here, my x-coordinate is -1. At 3 pi over 2, down here, my x-coordinate is 0. And at 2 pi, my x-coordinate is 1. So if I were to graph this, 0, 1 this time, pi halves is 0, pi is at -1, 3 pi over 2 is back to 0, and 2 pi is back to 1. This is one cycle, one period of the function. So let's answer that same question here. Let's talk about what is the period, what is the domain, what is the range. This is one period. One period goes from 0 out here to 2 pi. That's the distance it takes to do one cycle of its function. Now again, does it stop there? No. What does it do? It continues right on in this same fashion forever. So my domain is still -infinity to infinity. My range, how low does it go? How high does it go? Still bounded by -1 to 1. If you're curious as to why the sine and the cosine never get bigger than 1 and never less than -1, it basically lies in this area. Remember how we originally did SOHCAHTOA and we talked about like cosine was the adjacent over the hypotenuse? And we know that the hypotenuse has to be bigger and then the top has to be less. So whenever you have a smaller number on top of a bigger number, it's impossible to have like a cosine value or a sine value that's bigger than 1. It just can't happen. Now comes the creepy weird one, the tangent function. That's going to take a little bit of doing here, but bear with me. By definition, tan function is not the y-coordinate, it's not the x-coordinate. It is the ratio or the division between y and x. So if I want to find what tangent of 0 is, not theta, but 0, I need to go back to 0, take its y-coordinate, and divide it by its x-coordinate. So let's do that. Again, I know I've goofed up this unit circle, well, a lot. You know, I think I'm just going to draw another. Nah, I'm just going to go with this. So at 0, right here, this is my angle 0, right on the positive x-axis. My y is 0. My x is 1. So my y of 0, my x of 1, 0 divided by anything gives me 0. Let's now do what happens at pi halves. Again, back to our unit circle. Here's pi halves. My y is 1, and my x is 0. So I'm going to take my y of 1 and divide it by 0. And last time I checked, that was bad news. That is undefined. So how do I graph an undefined on one of these graphs? Basically, at pi halves, you have a vertical asymptote. It does not equal it. It gets close, it just doesn't touch it. Okay, let's keep going here. So if I go to, see, our next angle would be at pi, I guess it would be. So tangent of pi. We go back to our unit circle. Here's pi right here on the negative x-axis. Y is 0, x is negative 1. So y is 0, x is negative 1. 0 divided by anything is 0. And then let's do tan 3 pi over 2. Again, we go back. Here's 3 pi over 2 straight down here. At 3 pi over 2, my y is negative 1, my x is 0. So I get negative 1 over 0. That's that undefined thing again, which means let's just throw on another asymptote just for good measures. And then let's do 2 pi. And remember that 2 pi is the same as 0. It's just one revolution around. So it is also going to be 0. Wasn't that fun? Actually, it's kind of a lame graph. What I see is a few asymptotes, a few zeros, and no idea what goes on in between. That's why I made this table a little bit bigger. So let me just talk about the asymptotes again first. You'll notice I get asymptotes here at pi halves and 3 pi halves. So basically every odd multiple of pi halves, I have an asymptote. So I'm going to have one back here at negative 3 pi halves. And I'm going to, at negative pi halves, excuse me. And then also at negative 3 pi halves. It's periodic. It's going to keep repeating. And then another one at 5 pi over halves, 7 pi over halves, 9 pi over halves, 151 pi over halves. All those multiples, odd multiples of pi halves, I have the asymptotes. And then I'm also going to have zeros in between them. Okay? So there and there are zeros. So what happens in between? Let's erase a little bit, and I will do my best to show you. Or erase a lot, I guess, as the case may be. So, if I'm doing tangent of pi over 4, you can do this on your unit circle, you can do it on your gang signs, but basically, remember, it's y over x. If you're using your pi over 4 finger, and you all know which finger that is, that's your nasty one, you basically get root 2 over 2 over root 2 over 2, in which case the top and the bottom are each equal, which means it's 1. So pi over 4, it's 1. So from the 0, it goes here, and it wants to touch the asymptote, but the asymptote says no. Let's do 3 pi over 4. Well, here's what I know about the tangent of 3 pi over 4. I know that tangent of 3 pi over 4, or for that matter, every little pi over 4, is going to be either a positive 1 or a negative 1. It all depends on which quadrant it's in. So let's make ourselves a little unit circle. There's 0, pi halves, pi, 3 pi over 2, and 2 pi. Okay. Pi over 4 is here in first quadrant. That's where all functions are positive. That's why it's positive 1. 3 pi over 4 is in this quadrant. Remember, all strippers take cash. So the sign is positive, which means our tangent at 3 pi over 4 is negative. So 3 pi over 4, we're here at negative. And again, it goes in, gets close to the asymptote, just doesn't touch it. Okay, 5 pi over 4. There's 5 pi over 4. So that's my takes quadrant, or my tangent quadrant. So 5 pi over 4, that's going to be positive. And then the last one here at 7 pi over 4, that's my cash quadrant. My cosine's positive. My tangent is negative. So there's what we got. So just by kind of examining here, you see how I'm here at the 0? As I go to the right of the 0, it goes up. As I go to the left of the 0, it goes down. So here, right up, left down, right up, and so forth. And it's going to continue that pattern all the way through. So what is considered one cycle of the tangent function? This is. By definition, when we talk about one cycle of the tangent function, I'm going to go from the asymptote at negative pi halves to the asymptote at positive pi halves. That's what we're going to define as one cycle of the function. So let's erase. Let's talk all that fun stuff here with domain, range, and all that fun stuff again. Easy one to do is going to be the domain. Or I'm sorry, is the range. Forgive me for I have sinned here. The range is going to be the easiest one. Because the domain, it's not like from negative infinity to infinity or 2 to 5 or whatever. It skips stuff. So the range, I'm going to start with how low do these go? How high do these go? Well, in this case, they go from negative infinity to infinity. My period, how long does it take for it to do what it's got to do? Well, it does it from negative pi halves to a positive half of a pi. That total distance is pi units. Now the domain. What's up with that? Well, basically I'm good for all real values except where those asymptotes are. So my domain, I'm just going to write it like this. I'm going to say x is all real numbers except x cannot equal, I guess the best way to describe where all those asymptotes are at odd multiples of pi halves. Okay? So let's go ahead and close up this video and just kind of go over that a little bit. So my sine, remember it went on and on forever in the left and in the right, no issues. Same with my cosine. The range, remember it got never any lower than -1, never any higher than +1. Same thing with the cosine because the adjacent or the opposite can never be bigger than the hypotenuse. And the period, it always took it one full trip around the unit circle to do what it's got to do. Tangent, however, X is bad news, or the function tangent is whenever X is an odd multiple. Forgive me for my dreadful handwriting here. Surprised I passed kindergarten. Odd multiples of pi halves are bad. My range goes from negative infinity to infinity, and the period is just pi. It gets everything it needs in just half a trip around the unit circle. If you keep around the unit circle, it just repeats the same pattern again. I will post a video on like the transformations, you know, like remember how we did the transformations first semester with vertical shifts, horizontal shifts, reflections, and all that. I will post a video on that, and I will do that later on this afternoon. Rock on, guys. Bye.